Welcome to part 14 of the Metasploit Mega Primer. First of all, sorry for the delay in posting part 14. The reason was that I was a bit sick and hence could not make any videos. In this video, we will look at something very interesting which we can use Metasploit to do, which is backdooring executables. Now, one of the interesting things Metasploit can do is that it can take any payload and create an executable out of that payload. To do this, we will use the utility MSF payload. Let's actually go to our prompt and look at how this utility works. So let's run MSF payload with the less command to figure out what is the syntax. Okay, so the usage is MSF payload, name of the payload, then to give basically a name equal to value pair depending on what the payload expects. And then you could instruct MSF payload to do various things. First is give a summary of the payload. Second is the kind of output you want. We are specifically interested currently output as an executable, right? So let's search for a payload we are interested in. We'll take our favorite one, which, as you can guess, is the Windows Metapreta bind TCP payload. So in order to figure out the different options, give it the payload and give it the S option to give you a summary about that payload. This will help us understand the different name equal to value pairs to be used. So if you notice in the options, well, exit function, let it remain in the current setting. Local port, this is the port on which the victim will bind our Metapreter to. We'll leave this setting as is. Our host is the target address or address of our target. So to know this, let's go to our target and print out the IP address. Seems to be 10.10.10.150, right? Now we basically want that an exe file be created with this payload. So in order to do that, we'll use this command. Give it the options, our host equal to 10.10.10.150, and then go ahead and tell it to create an executable, and then probably we'll give an executable name bind_tcp.exe. Right? If we do an ls now, we'll find bind_tcp.exe in the same directory. Now let's go ahead and actually copy this to our web server directory. I'll just tell you in a minute why. Now, basically, this exe has to be delivered to the victim computer somehow, right? This could be over the web where the victim is probably forced to view a page and some download happens, or he goes ahead and tries to install a software which contains our payload, or many other options, right? So in this case, we will assume that the victim is going to go ahead and use his web browser to download this software somehow from our website. So let's navigate to our web server's IP address. So we'll go into the utilities directory, and here is the file which we will save and run. So exactly how you end up delivering this to the victim, we will look at a couple of techniques using the social engineering toolkit in the end. I'll probably more of give you a link to the site where you can explore. So we'll keep that aside. For the time being, let's assume that the victim somehow receives this exe and is going to run it. So he receives it, he runs it. If you notice, there's a little feeling as if the exe was run, but then it looks like it just exited. But if you look at the task manager, you will notice that it is actually running in the background, right? So how does one go about connecting with this? Well, we'll go to a Metasploit terminal and actually go ahead and use the multi-handler exploit. Now we have to set the payload to be exactly what was delivered to the victim, which is Windows metapreter bind underscore TCP. Then we'll have to figure out the different options. The port remains 444, but we need to figure out the victim IP address, which is 10.10.10.150. Now from here, all we need to do is hit exploit. Now if you notice, this is connected to the victim, sent the second stage, and we have a metapreter session on the remote computer. Awesome. From here, what all we can do, we've discussed it in very much detail in a lot of videos. So I won't get into what we can do from here. The whole point was to use an executable and to get a remote session. Now, one of the things which you need to know is that this session is only created one time. In the sense, currently bind tcp.exe is running, but the moment you go back here and exit from this metapreter shell, if you come back, you will notice that the bind TCP process is also exited. Now you can do a lot of interesting things about how to make this persistent. We've discussed some of them. You can also use the schedule me metapreter script to go ahead and add this to one of the lists of programs which are started at a particular time or even at initialization by modifying some registry keys. A lot of things can be done. Classic examples include metsvc and the persistence script. You can borrow a lot of ideas from them. Anyway, coming back. So this was demo number 1. Now, the other demo which we will do is, let's go back to the slides. Okay. Now, if you notice, the exe which we shipped to the victim was containing the payload as is. Now, this can be a problem at times, right? Because at times you might want to evade detection by antiviruses, and sometimes what you would notice is, depending on how you run the payload, you might want to go ahead and remove certain characters from it, like nulls, etc. Right? So the basic idea is to take the base payload and to encode it. Now think of encoding as just going ahead and transforming from one form to the other. The functionality of the payload remains exactly the same, but if somebody would look at the exe with a microscope, the individual bytes would end up looking quite different. To do this, we will use the MSF encode utility in conjunction with MSF payload. Let's look at how we do this. So we'll bring back our basic, let's go ahead and hit MSF encode with a -h to figure out the different commands. Now there are a lot of options which you can go ahead and explore. The one which is very important is this, the number of times to encode. This is basically somewhat of a repetitive encoding, which is you encode the base payload, then you encode this encoded form, then you do that again, so on and so forth. So with this, you can specify the number of times. Another important input is the encoder to use, which you can very easily figure out by going ahead and running the show command with show encoders, right? And then is basically one of the other interesting commands is the name of the output file, right? So if you notice MSF encode, well, we will have to feed the raw stream of the file to it so that it can encode it. So what we will have to actually do is go ahead and use MSF payload, but not tell it to create an exe. Instead, we will just go ahead and tell it to output in raw mode the payload. And then we will pipe this to MSF encode. Right? Now we'll have to go ahead and select an encoder. The most popular one always seems to be Shikataganai, which actually is nothing but a polymorphic XOR additive feedback encoder. And from there on, the number of times to encode, generally 4 and above is quite good. The output file, let's just name it bind_tcp_encoded.exe, right? And one of the other important formats is the -t option, which basically we'll have to give it as exe because we want the output to be an exe file. Okay, so let's go ahead and run this. May take some time. So if you notice, the encoding has done, 4 iterations are over, and the exe file has been created, right? We'll copy this exe file to our web directory into the utilities folder. Then we go back to the victim machine, go to the web server, refresh, copy it on the desktop, and let's close this for the time being. Let's go back here, and now we can run this encoded form. Once again, nothing seems to happen. One interesting thing, if you would look like, is back here. So it's the older version, right? The file size pretty much remains the same. One of the interesting things, even post encoding. Now, what we will do is to connect to this exploit running remotely. All we have to do is, once again, type in exploit in our multi-handler. So the whole thing continues, and basically we have our Metapreter shell, right? And as soon as we exit the remote program, which is bound to that port, will also exit. Let's go back here, exit. So one of the key things, if you notice, is that we've gone ahead and created these executables which allow us to actually create backdoors on the system. Now, would it be not more interesting if we could make this executable almost look exactly like a normal executable? For that, MSF encode has an interesting option called use executable template, where we can take an existing executable and go ahead and add this payload to it. So when that executable will run, actually the payload ends up executing, right? One of the other things you could also do is basically use a program like Resource Hacker and go ahead and take the icon and a lot of other things from an existing executable and add it to this piece of backdoored executable which we've created. I'll leave that as an exercise to you. Resource Hacker is the name of the program. Now coming back here, what I've already done is in this directory, I have downloaded notepad.exe. This is the typical notepad program on a Windows system. Now I'm going to backdoor this program. So before that, if we do a -h on MSF encode, the option to use an executable is the -x option, right? So we'll take the exact same command, add the -x option, give it notepad.exe, and we will actually come here and probably rename this notepad2.exe, right? Go back here, run this command. Now in our directory, we have a notepad2.exe. Now, one of the interesting things which I want to point out is, if you notice, there is no change in the size of the file, which is pretty good, right? Now we will transport notepad2.exe to our web directory. And then we'll go on the victim machine, refresh the same directory again, and copy this file to desktop. And one of the interesting things you would notice is this exactly looks like the Notepad program, even from a visual icon perspective, right? But however, the moment you execute it, well, basically our payload executes. So the original Notepad program unfortunately does not open, but our payload executes and is currently in memory, right? To connect to it, as we've already mentioned, we will just use the multi-handler exploit. We've already set all the attributes required, and that's it. Using this, we have a Metapreter session, right? Let me exit. So one of the disadvantages, if you've noticed, is that the original program itself did not run, which is bad because this will actually trigger some suspicion from the user's side. So is it possible to go ahead and run the original program and also our payload? Well, yes. The Metasploit team has done an awesome job. And in order to do that with an existing executable, you have to use the -k option. So this basically says keep template working, run the payload in a new thread. So all we have to do is take our previous command and actually just add -k to it. Let me call this notepad clone.exe, and let's go ahead and run this. We'll wait for a bit, and now we have the notepad clone.exe. One of the things which you would want to notice is the notepad clone.exe is different in size, actually more than the original file. The reason I'm mentioning is one needs to be aware of what really happened. From a forensics perspective, what are the different things which could be overlooked at this point by the attacker. Anyway, we'll copy the notepad clone into the web directory once again. Go back to the victim, refresh the web directory, copy the file, come back here. Now let's run this clone. If you notice, Notepad has opened absolutely flawlessly, right? We can even go ahead, type, save this file, whatnot. So the original program has not been tampered at all. But the beauty is that it has already started our payload in a different thread. So the moment we hit exploit, it automatically connects to the remote system, right? And if we do a PS 2148 is nothing but of Notepad. So we are actually connecting to this program, which has also opened up a remote port using which we have broken into the system, even though the program itself is working perfectly fine. Now, as you can imagine, the user might close this program almost immediately. So it might be a good idea to migrate from this program to some other process which is running like explorer.exe. Anyway, we've looked at all of that in much detail, so I will not show that to you right now. So to go ahead and conclude, we looked at a couple of things: how to take a payload, convert it to an executable, running that executable on the victim system by some sort of social engineering, then connecting to that system. You could also have used a reverse connect by using a reverse underscore TCP with Metapreter. I'd leave that as an exercise to you. Then we learned how to encode the payload using different encoders multiple times if required, and then creating executables. This typically will be used to beat antiviruses. And then after that, we also learned how to take an existing exe file and add the payload into that file. Here there are two variations. One is in this new file, when it is double clicked and run, only the payload runs, the original program does not work. And the other more clever variation is to run the payload in a separate thread. Right? Awesome. Now let's look at two important concepts. Another very good way to go ahead and evade AVs is packing executables. Now, packing is nothing but compressing the executable. And the way in which this compressed executable runs is that first there is a small piece of code which unpacks the original code and then transfers control to it. Typically, if you look at the origin of packing, it was actually used to decrease the storage required for an executable. But slowly it started getting used by viruses and worms to even evade AV programs. There are multiple packers available: UPX, PPack, ASPack, whatnot. I'll leave this as an exercise to you to take executables and pack them. Packing, currently there's no utility in Metasploit using which you can do it, but I think there are tons of packers out there with which you can experiment. Now, one of the important things which we did not look at was how to have a gullible user go ahead and run this backdoored executable. Well, there are tons of technique, and this is exactly the reason why the social engineering toolkit was born. So SET, of course, has a lot of other things like using Java applets to break into systems and so on and so forth. But one of the interesting ones include actually sending the user an email with probably the executable or the payload encoded in a PDF document, and many of these variations. I would go ahead and encourage you to explore SET. SET, all sorts of videos are available on secmaniac.com. This is the website of Social Engineering Toolkit itself. You'll find tons of videos by David Kennedy, who is the author of SET. Also on our very own securitytube.net, if you search for Social Engineering Toolkit, you would find a couple of good videos contributed by our users. So this is the website secmaniac.com. You could go to the tutorial section and you could actually click here to look at all these different movies which have been created by David Kennedy on SET. Right? Tons of them. You can download the tool and use it. Backtrack also has SET included in it. You could just go to this directory and you can go inside SET and you can actually run SET from here itself. Right? So explore this tool. There are tons of videos which have been created by David already, and hence I do not want to repeat something which he has so perfectly already done. Right? Well, that's all for part 14. Hope you enjoyed this session on backdooring executables. Like always, I read each and every feedback and comment which you give, and I'm really looking forward to the comments which you would leave behind for this session. That's all. Thank you. Keep having fun.